Hello, today we are going to revise Storm, which is a reliable and real-time analytic framework for online machine learning or continuous computation, which depends on distributed RPC. We had seen how it is been processing multiple tuples and still fault tolerant. Then we had discussed about Spout, how the streams and resource of a stream are being managed with topology. Then we had seen Bolt, how the bolts are being connected for the topology purpose, for doing filtering functions like aggregation, join, talking to the database type of things. Then we had also seen how the topology and how the uh, map reduce its analogous to map reduce, and how it does the job processing and all the graph related issue it solves, and how the spout and bolt work with the topology. Then we had also discussed about stream, how the stream of the real time data was coming and being processed by the storm. Next, we had also discussed about the Google file system, where it is a kind of scalable distributed file system analogous to the Hadoop distributed file system, and it can have the high aggregated performance for the large number of clients. It was being called as big files earlier, being developed by Larry Page and Sergey Brin. Then we had discussed about the Google content management, like it manages Google Cloud Platform and services for the content management systems. Then how it manages Google manages load balancing. Then how it do cloud DNS domain name server, and having the static content management and dynamic content management for cloud storage and cloud SQL implementation respectively. Then we had discussed the architecture of Google Cloud Management, like it has compute engine, cloud storage was there, cloud SQL was there, Google Load Balancer works. Then it has architecture of Hadoop on the Google Cloud, how the MapReduce being managed on the Google. We had means seen that we it also Google also provide Hadoop master and node for doing the map processing, where the data node stores the data and map reduce task runs, and it do the backup of the data which has been processed and which is going to be processed. So all, both type of input and output data was being backed up, and this was the architecture of the Hadoop Google Cloud. Like client was connected with the compute engine that was further connected to the input data, which is cloud store, and then output data, which is cloud storage again. So how the input and output was being managed with the Hadoop MapReduce task is it's the architecture of that in the Google Cloud platform. Then we had discussed Google App Engine, where the web application are being deployed for in-memory distributed cache processing and having the efficient auto-scaling type of feature. It works with Java, Python, PHP, Go. Then it also helps you to do A/B type of testing. Memory cache was there, where in-memory data was being cached, and which provides you the high-speed access over the network. Then you have task queuing process, load balancing also being provided by the Google App Engine. Then Google Cloud DNS also used to manage the domain name server for the users. This was the architecture that we had seen, which has Google Load Balancer first, then App Engine working in the backend, Cloud Store, which is static content, and dynamic content, which is Cloud SQL and Cloud Data Store. And the Google App Engine keeps on communicating with the memory cache, which is type of edge computing or the kind of server which is providing memory and data faster. Then task queuing was being properly scheduled. Then App Engine works, and also have the Google domain name server. Then this was the Google Web Toolkit, which is a kind of API which actually helps you to develop some Google App Engine based application, and you can deploy over the Google App Engine. So Google Web Toolkit help you do Swing like Java framework and HTML coding, JavaScript being embedded on the, and then desktop based development environment was very easy for developing with the Eclipse like framework in the Google Web Toolkit. Google Web Toolkit also provide debugging and unit testing of type of features. It actually runs on a small host machine, and you can develop and debug the code in the local machine itself. Then you can deploy at the end and execute the code over the Google App Engine. Then Google Web Toolkit is useful for site management, and it can also communicate with the Google Docs, Google AdSense, Google Wallet, and the other sites also can be synchronized with the help of Google Web Toolkit. Then we had discussed about the Eucalyptus Cloud, which has the three different component, like cloud level component, which helps you to do management of whole cloud, which has the part cloud controller and scalable object storage. Then the further lower level has cluster level, which actually helps you do cluster management, storage management, and virtual machine broker kind of things. Then the fundamental node level means atomic level of thing is node level, where you can have distributed over the machine. So the how a single machine was being managed, it was managed with the help of node controller. Next, this was the architecture of the Eucalyptus Cloud, which has the Amazon compatibility APIs, and then you have the cloud management, where the cloud controller and scalable object storage works. Then you have the cluster controller, cluster manager was there, storage controller was there, VM broker, and node controller, where the actual virtual machine are being deployed. And we had seen Ruby on Rails, where the application are being deployed over the framework, and it has the model view controller and has the convention over the configuration management, where you have more purity for the front end part, and you keep the separate database part. This was the architecture that we had seen. Client communicate with dispatcher, controller, and it goes for the action view, and then action web service, mailer, and active records database management. And this was the architecture that we had discussed. Next, Ruby on Rails supports RESTful architecture, means representational state transfer, which is an alternative of web service based on SOAP and WSDL, and it works on the CRUD, means create, read, update, and delete. Then RESTful is a stateless transfer protocol, so it's advanced form of web service management. And model view controller, we had discussed how the HTML pages are been working with the backend. So architecture was planned with the model, which is actually having the business logic and the basic code. Means if else loop, for loop was there, and all the type of fundamental coding you do at the model part, where you do the management of databases and interact with the database. Then you have view, which is like a HTML file front end of the Ruby code, and then you can have XML type of thing, RSS type of thing in the view. Further, the controller means decision making type of thing, and it controller interact with both model and view. And incoming requests are being processed by the controller, and controller also processes the model and passes it to the view. Next, we had discussed SOA, grid, and cloud computing in detail. And the common architecture of all kind of such thing is like interface layer was there, middleware layer was there, resource layer was there. Interface layer desktop, middleware soap type of thing, and resource layer means high performance computing type of thing. Next, there's difference between URL and URI. URL are for the humans, for the browser management type of thing, but the URI is for the machine to machine communication purpose, where the client communicate with the particular web service. Then we had discussed how web service are being invoked. It first do discovery, then it replies for the discovery, then web service descriptive language was being called, then SOAP request and method invocation means logical programming was processed, and then the SOAP response will be come to the client. So this was the web service invocation. We had studied marshalling and unmarshalling, means creation of stubs at client end or at the server end, where the SOAP requests are being marshaled, and then the HTTP protocol was being followed to send the client stub, and then unmarshalling will take place, means deserialization of SOAP request. Then the server stub, then the process of that request was being done, and the server stub being created, and that server stub being set to the HTTP protocol, which was further being unmarshaled at the client part. Then this was the fundamental architecture of web service invocation, web service, then SOAP engine, then application server, then HTTP server. We had seen grid architecture. It has grid, means older type of cloud computing has fabric layer, means resources, network, code repositories are there. Then connectivity layer, which is having the network communication, authentication protocol type of thing. Then it has resource layer where you have the discovery, negotiation, monitoring type of things. Then collective layer means monitoring, discovery, and management type of things. Then application layer, where we had seen the VO environment and APIs works at the top level of the architecture. Then the cloud architecture, which is analogous to the grid architecture, has fabric layer, means resources was the common in between. Then unified resource layer was being there, means virtualization was there, logical file system, cluster management was there, database management. Then cloud architecture also have platform layer, where you have a specialized tool for middleware, and you have the development environment over there, web hosting type of thing. Then front end part means application layer was there. Application layer was front end type of thing which runs on the front end of cloud. So this is the analogous between the grid and cloud architecture, where the all the layers are being influenced between fundamental service technologies, where application layer was common. Then collective and resource layer are being combined and said to be platform layer in cloud architecture. Then connectivity are being analogous to the unified resource. Then fabric layer was common in between. Next, we had discussed transactional or on-demand and the distributed computing. So we had seen CAPS theorem, where it was said that consistency, availability, and partitioning, all three couldn't met simultaneously. It's We can't guarantee that all the three could met at the particular single instance of time. Means all the three could possible some of the times, but some of the times due to some failure, one of the thing could get compromised out of the three. So this means that simultaneously you can't have three things all together with a guarantee. So guarantee word is the important in this. Next, no SQL means where you do not only required SQL, and it can work without SQL as well for the relational or tabular data. And you have various SQL query type of system as well in the no SQL, but it is having above, means more than SQL things, which is also having no SQL also have key value pair, graph, document management, high usage of big data, then real time web application was there. Mostly NoSQL servers or the database systems are based on the CAPS theorem. Then the low level query language and interface and huge investment of the SQL was there. So it is difficult for a company to move from SQL system to the NoSQL system. Then we had seen some of the property of the NoSQL does not being provided by the NoSQL, means asset properties. Some of the asset properties are not being provided by the NoSQL. Then we had seen the categories of the NoSQL databases, like it has column oriented databases, document oriented databases, key value pair databases, graph databases we had seen, multi-model type of databases belongs to the NoSQL database. Then on-demand computing, it's fundamental of cloud computing. To conclude our work over here, that the cloud computing has based on the on-demand computing, which is actually serves the enterprise level, and which is based upon the CPU cycle, bandwidth, availability, storage, and application management. Then it has the big data management type of thing. HPC was there, where you can show that the infinite illusion of the resources were there. Then we had discussed about the distributed computing for concluding the whole cloud computing architecture, where we had seen grid utility and cloud computing are the branch of distributed computing. Whatever we are saying in the grid utility cloud are actually subset of distributed computing. In And all these distributed computing are based on the fundamental fact that remote procedure calls works for message queuing and processing part. So this is how we had concluded the distributed computing for the network based type of thing. And these are the references that we had seen. So thanks for the discussion, and then we'll see next in next class.